Let us solve this question. A steel rod of 30 mm diameter is enclosed in a brass tube of 42 mm external diameter and 32 mm internal diameter. Each is 360 mm long and the assembly is rigidly held between two stops 360 mm apart. The temperature of the assembly is then raised by 50 degrees centigrade. Determine first stresses in the tube and the rod. Second, stresses in the tube and the rod if the stops yield by 0.15 mm. So this is a question of thermal stresses in which we are given with steel rod which is enclosed in brass tube, and then the temperature of the assembly is increased by 50 degrees centigrade. There are stops so that there should not be any expansion in the bars and the tubes, so that the stresses will be developed in the tube and the rod. So we have to find in first part the stresses in the tube and the rod. Now in the second part, if there is yielding of the steel and tube by 0.15 mm, then what are the stresses developed in the assembly? So this is the question. Let us solve this question. This question is regarding thermal stresses. That this is a section given in which there is a steel bar and there is brass tube, and steel bar is inserted in brass tube and there are rigid supports which are stoppers here, which are stopping the steels and brass to expand when the temperature rises by 50 degrees centigrade. It means that the expansion is restricted, and you know that whenever expansion is restricted in temperature stresses, the stresses are developed in the material. For free expansion there is no stress developed, only strain is there. But if the expansion is restricted, you are not allowing the material to expand, then there will be stresses developed in the material, and the stresses will be compressive stresses. So basically the material want to expand like this. There may be some expansion which would have been there if there is free expansion, but this expansion is restricted by this reaction of this rigid supports, right? And the modulus of elasticity of the steel and brass is given, and the coefficient of thermal expansion of both the materials is given. We have to find out the stresses in steel and brass when there is no yielding. It means the stops are at as their points 360 mm apart. But while expansion, there may be chances that due to loose connections, there may be some yielding of the supports. These stoppers are yielded by some amount, that is 0.15 mm. So stresses developed will be reduced, and we have to find out then what are the stresses when there is yielding of 0.15 mm. We denote it by delta. So this we have done in our theory lecture, that this is the formula. We are using directly formula here because we have already derived these formulas in our theory lectures. So when the stress developed for no yielding is alpha Te, and if yielding is there, the stress developed is this, and delta is the yielding, right? So we can solve it now. The stress developed will be compressive in both the materials because we are not allowing the material to expand. So stress developed is sigma s, and sigma s compressive. Also the stress developed in brass will also be compressive because same thing is compressing this also, right? So this is steel rod, and this is brass tube, right? So what is the stress developed? Stress developed in steel, sigma s, that will be equal to alpha Te, alpha T and E. Alpha of the steel, T temperature rise, and E of the steel. So that will be equal to alpha 11 multiplied 10 to the power minus 6. 11 10 to the power minus 6 multiplied by temperature rise is given 50 degrees centigrade. So 50 degrees centigrade multiplied by Young's modulus of elasticity of the steel is 205 gigapascal. If you make it megapascal, then the answer will come in megapascal. So that's why I am multiplying it by 10 to the power 3. Solve it and try to get the answer. You will get the stress in steel as 112.75 megapascal. So one of the answer we have obtained, that is 112.75 megapascal, the stress developed in steel, and this will be compressive stress, right? This is one of the answer. Now the stress developed in brass, sigma B, that is equal to alpha of B, T and E of the brass. So alpha of brass is 19 multiplied 10 to the power minus 6, 19 10 to the power minus 6 multiplied by temperature rise, and EB is 90 gigapascal. Make it megapascal by multiplying 10 to the power 3, and the answer will come in megapascal, and you will get the stress in brass as 85.5 megapascal. 85.5 megapascal. So another answer we have got is 85.5 megapascal, and the stress is again compressive stress, right? Now in the second part of this question, the yielding is there, and the yielding is, how much yielding is there? That is 0.15 mm yielding is there. Sports yield by 0.15 mm, right? So what will happen? The stress is developed in this material. So stress is developed in steel will be equal to, alpha of steel, T minus delta is common to all, L is common to all, and E of steel. So we will get alpha of steel 11 multiplied 10 to the power minus 6, T is 50 minus delta 0.15 mm. So both if we take an mm, then mm will cancel out. So 0.15 by length will also take an mm. So 360 mm. So 0.1 by 15 by 360. So this is delta by L multiplied by the E. E of steel is 205 gigapascal. So 205 multiply 10 to the power 3. So answer will come in megapascal, and you will get 27.33 megapascal. This is the stress developed in steel if there is yielding, and you will be, and this is also compressive. This is still compressive, and you will see that the stress would have been very reduced. So this was 112 and now it is 27.3 because there is yielding of the stoppers are there, and the stress will reduce, right? And sigma B dash, the stress in brass, that will be equal to alpha of brass T minus delta by L multiply E of brass. So that will be equal to alpha of brass. Alpha of brass is 19 into 10 power minus 6. Temperature rise 50 degrees centigrade minus yielding is 0.15 divided by total length is 60 mm multiplied by the modulus of elasticity of brass 90 and make it megapascal, so that answer may come in megapascal, and you will get by this the stress developed in brass due to yielding, and that is 48 megapascal, and it will be reduced from the previous one when there was no yielding. So this is also compressive. So these are the stresses developed in steel and brass when there was no yielding and when there was a 0.15 mm of yielding of the supports were there.